Choosing spectator ions to use for solutions or salt bridges. In this notation, spectators are not present. We've already chosen our strongest oxidizing agent, our cathode side, our strongest reducing agent, our anode side. The anode will lose electrons, undergoing oxidation. The electrons will leave the anode and go to the cathode. The cathode side will undergo a reduction reaction. Since the anode side is going to lose electrons, this side is going to become more positive. Since the cathode side is going to gain electrons, this side is going to be more negative. Now, there's an imbalance of charge. The anode side is more positive. The cathode side is more negative. This is where the salt bridge comes in. The salt bridge ions provide the solution to the problem of imbalanced charges. Now that we've identified anode and cathode, that there's an imbalance of charges, we now use our spontaneity rule to choose any aqueous solution that will not react with the original strongest reducing agent and original strongest oxidizing agent. We don't want to interfere with this spontaneous reaction. So we need to choose something that will not react with the dichromate and protons, and something that will not react with the iron 2+ strongest reducing agent. Let's look at an example. Sodium chloride in water, sodium chloride aqueous, dissociates into sodium ions and chloride ions. As you can see, the chloride ions are RAs that will not react with the strongest oxidizing agent. Also note that sodium ions are OAs, but very weak OAs that will not react with the iron 2+ strongest reducing agent. Since they don't react, we can consider them as appropriate spectators for this situation. We also know that nitrates and sulfates tend to be spectators by themselves when they dissociate from an ionic compound. That is, if they are attached to a group 1A or group 2A metals, they will not react as well. For example, we have calcium sulfate, dissociates into calcium ions and sulfate ions. The calcium ions are very weak oxidizing agents that will not react with the strongest reducing agent. Sulfate by itself is not on the list, therefore it's originally a spectator. Sulfate with water, though, is on the list, but again, it's a very weak oxidizing agent that will not interfere with this spontaneous reaction. Can you think of other combinations that would be good spectators for this reaction? Now to summarize, we have a salt bridge. We can choose either calcium sulfate or sodium chloride because neither ions will interfere with the original reaction of SRA and SOA. Remember that there was an imbalance of charges. The anode became more positive and the cathode became more negative. The salt bridge provides a solution that the cations in the salt bridge will move towards the cathode. The anions in the salt bridge will move towards the anode to balance and have a neutral solution.